After studying this module, you would be able to understand the asset market equilibrium. You would be able to derive the real LM function, also the slope of the real LM function, and then you would be able to study the effects of fiscal and monetary policy. Asset market. What is an asset market? Ordinarily, we understand the asset market as the money market. What is money? Money is a generally accepted material which is used for transactions and for discharging financial obligations. In this sense, money supply is equal to CC plus DD plus OD. CC is currency notes and coins held by the public, DD is demand deposits held by the public, and OD are other deposits held by the central bank. Now, in practical terms, OD is a very small component, so let us stick to the definition of CC plus DD. Therefore, if we look at the money market from the point of view of the liquid wealth being held as between a cash balance or in the form of a short term bond which yields some return or rate of interest, then each investor or household has a choice between holding their wealth as money or in the form of short term instruments like treasury bills or so on. Now, the asset choice that is involved makes this market also attain the name of asset market. Now, here let us now consider the demand side of money. On the demand side, there is demand for holding money for transactions and precautionary purposes, which is known as M1, and for speculative purposes, which is known as M2. Therefore, in the first equation, we see that money demand is equal to M1 plus M2. Now, M2 is a function of rate of interest and M1 is a function of real income. Therefore, if we put these two together, equation number 2 says that money demand is equal to M1Y plus M2R. And if we further simplify this, then we could say that money demand is equal to KY, which is the proportion of real cash balances, and LR, which shows the functional relationship between speculative balances and the rate of interest. Now, if we consider the slope of the M1 function, then KY would be positive, that is the slope or the derivative is positive, and the derivative of money demand with respect to rate of interest, that is L prime, is negative. Now, if we look at the money demand in real terms, it would be M divided by P, which is the general price level. This is denoted as small m. That is what equation 4 tells us. If we take price level onto the right hand side, then equation 5 is telling us that money demand when multiplied by the price level becomes nominal money demand. On the other hand, if we take it back onto the left hand side, then M upon P is denoted with small m, and small m, which is the demand for real cash balances, is a function of R and Y. Thus, real money demand is a demand for real cash balances and it depends upon real income and real rate of interest. Derivation of the real LM function. On the supply side, we know that the money supply is given, it is equal to M bar. So, money supply is also defined in real terms, therefore, we could actually say this is M bar upon P. And we have already seen that the M1 is positively related to the level of income. Therefore, if M1 is positive function of y, as the income level increases, the transactions demand also increases, and you would see in the diagram that M1 increases from M1 Y1 to M1 Y2 to M1 Y3. Correspondingly, the money demand also increases, and accordingly, through the intersection of the supply of real cash balances and demand for real cash balances, the rate of interest also increases from R1 to R2 to R3. And in a given situation, if the rate of interest does not adjust to the excess demand that is there in the economy, then the money market or the asset market would be in disequilibrium. Therefore, the rate of interest is bound to rise as the money demand increases from MD1 to MD2 to MD3. And this, of course, is when the real supply of real cash balances is given. Now, this happens because the increased M1 has to be substituted by a reduced M2, and M2 will fall only when the rate of interest rises, because there is a negative relationship between M2 and rate of interest. Now, the money supply, we know the real supply of cash balances is M bar, which is constant, nominal money supply is constant, divided by P is the supply of real cash balances. This should be equal to the demand for real cash balances, which is given by small m. This is our equilibrium equation number 8. Under these situations, what we can see is that the asset market in real terms is in equilibrium. Now, we are going to look at a different way of deriving the LM function, the real LM function, with the help of a 4-quadrant diagram. In the first quadrant, we would ultimately be deriving the LM function. So, therefore, let us take up the first quadrant at the end. We start by looking at one given level of real national income Y1. At Y1, what we see is that given the ky function, which is the function for M1, there is a given level of M1 Y1, transactions demand for money. And this transactions demand for money, when according to the properties of similar triangles, is translated onto the negative x-axis, then you would notice that out of the total money demand, which is measured on the negative x-axis, a part is M1 and the remainder is M2. So, this is M2 Y1, and the total money demand, which is M1 plus M2, has to be equal to the total money supply. Now, look at the negative y-axis. On the negative y-axis, we have a given level of nominal money supply divided by the price level P0, and this is the real money supply or supply of real cash balances. Under equilibrium, this should be equal to M, small m, which is the demand for real cash balances. So, if we consider the downward sloping triangular line, which is in the third quadrant, this is a line which tells us about equilibrium in the money market or the asset market. So, coming back to our question, that is, for a given real income Y1, there is a level of M1 Y1, which is transactions demand, and given the level of real money supply, if we equate it to the real money demand, then the balance of the money demand, which is the difference between the total money supply and M1, is M2. Now this M2 must correspond to a particular level of speculative demand which is desirable for a given rate of interest. And which should this rate of interest be? This rate of interest should be the rate of interest at which the product market is in equilibrium. That means that the level of income should be Y1. So, corresponding to the level of equilibrium level of income Y1, there would be a rate of interest, and that rate of interest is easily determined if we look at the y-axis. Then you would see that there is R1. At R1 we have got M2, and this M2 corresponds to the M1 for the given level of income Y1. So this rectangle is complete. Now similarly, if we consider Y2, then drop a perpendicular from Y2, it comes up to KY. At KY, we can easily see that the money demand due to transactions purposes M1 is dependent on Y2. So M1 Y2 gives you a larger money demand due to transaction purposes. But because the money supply is the same, and because equilibrium implies that money supply has to be equal to money demand, therefore M1 being larger, M2 has to be smaller. M2 can be smaller only if the rate of interest is higher. Therefore, let us again look at the equilibrium in both the markets. At Y2, we should have a rate of interest which is exactly corresponding to the level of income Y2. If the rate of interest were to be more, then M2 being negatively related to rate of interest, the M2 would be less. If the rate of interest is less than desirable, then the M2 would be much greater. So, please understand that there is just one rate of interest which corresponds to M2, which exactly gives you the level of income Y2. So, therefore, there is only one rate of interest R2. So, what do we have? We have one combination, that is R1, which goes along with Y1, and another combination which is R2, which goes along with Y2. So, therefore, we have an LM function, or we can derive an LM function by joining the 2 points R1 Y1 and R2 Y2. R1 Y1 and R2 Y2 clearly show that the LM function has got a positive slope. It is upward sloping. So, in this manner we have derived the real LM function. Here we are dealing with real demand for cash balances, real supply of cash balances, real national income, and real rate of interest. Now, let us consider the change in the money supply. That is, if the nominal money supply increases, then what would happen? The nominal money supply has increased from M bar to M bar prime. That is, the Reserve Bank, the State Bank, the Central Bank, it expands the nominal money supply. The price level is given, it is still P0. So, the supply of real cash balances has expanded from small m to small m prime, and this shows that there is a equation in the money market which has to be retained, that is the equation between the supply of real cash balances and the demand for real cash balances. Please look at quadrant 3. In quadrant 3, we are representing the equilibrium in the money market. So, in the money market you would notice that there is another parallel line which is shifted outwards to the left or downwards in comparison to the previous line which was representing money market equilibrium. This is because the nominal money supply has increased with a given level of money of price level. The real money supply has also increased. In this new situation, what do we expect? We expect that there is more of money in the economy. If there is more of money in the economy, then let us see in real terms, then let us see what happens to the relationship between the level of income which is in the product market and the rate of interest which shows and which is based on the equilibrium in the money market. Now let us again consider y1. When we consider y1, then given ky, nothing has happened to ky. The level, the shape, the slope of ky remains the same. So given ky, m1 which is a function of y1 would remain the same. The only difference is that if we measure m1 along the negative x axis, then it would not stop at the earlier money supply function, the triangular line, but it would go further and touch the new money supply function. Okay. So what happens is, while m1 y1 remains the same, because the total money supply has increased, so the difference between a fixed m1 y1 and an increased money supply would be much larger. And what is this difference? We know that m1 plus m2 is equal to money demand, and when money demand is equal to money supply, there is equilibrium in the money market. Therefore, I repeat that with a given level of income y1, the m1 remains the same, but to fill the gap, that is the excess money supply that has come into the market, to fill this gap m2 has to grow. But let us remember that m2 is negatively related to the rate of interest. Therefore, unless the rate of interest falls, m2 is not likely to grow. Therefore, please look at the rate of interest which is associated with y1, but it is at a lower level. This is R3. Okay. So given R3, we have a level of m2 which is fulfilling the gap between the same level of m1 and the increased level of money supply. Similarly, if we take the erstwhile level of income y2, and on similar lines if we take m1 y2 and proceed to the new money supply equation, the triangular line to the left of the old triangular line, then you would see that m1 y2 is going to remain the same. But then again, parallelly, compared to the old rate of interest, which was R2 in the case of the y2, what happens is that the rate of interest has to be lower. Only then the speculative demand for money will expand and fill the gap in this case as well. So now we have 2 points which correspond to the level of income y1 and y2 and their corresponding interest rates, that is R3 and R4. If we join these 2 points, then we have a new LM function L prime L M prime, which lies to the right, which shows an expansion of the new LM function. Therefore, if nominal money supply increases, we can see that the new LM function expands, and the same effect would be there if the price level falls, because we can see that real money supply would rise either if nominal money supply increases or if the price level falls. Let us now consider the slope, or let us derive the slope of the LM function. What we have seen so far is the shape of the LM function, and you would notice that the shape of the LM function is no different, a real LM function is no different from the slope of a nominal LM function. Now we are considering about the slope. The real money demand function is given by m upon p, or small m, which is equal to LR plus KY. This is given in equation number 10. So what do we say? That since the real money supply is given, the nominal money supply is given, and the price level is also given, m bar upon p is equal to 0. That means prime, m bar upon p prime, which means change in money supply would be 0, because the money supply is given and the price level is given. So if we consider an LM function, it is a locus of all such points at which equilibrium takes place. So if money supply is not changing, then the change on the right hand side of the equation, which is money demand, should also be equal to that. That means that if we differentiate the right hand side, then the right hand side, change in the right hand side should also be equal to the change in the left hand side. In other words, change in money supply should be equal to change in money demand. If we consider the money demand function, and if we take the derivative, you must remember that we must take the partial derivative with respect to the two variables which it depends upon, that is the rate of interest and the level of income. As we have just said, the left hand side shows that money supply is not changing, so therefore we put it as 0 equal to L prime, which is the partial derivative of money demand with respect to rate of interest, and into the dr, which is the change in the rate of interest, plus the partial derivative of money demand with respect to income, which is k prime, into the change in income, which is dy. So we have an equation 0 is equal to L prime dr plus k prime dy. And if we now take the income term onto the left hand side, it becomes minus k prime dy is equal to L prime dr. If this equation is manipulated and we wish to have the total derivative, that is dr upon dy, then it would be equal to minus k prime by L prime. Now we know that k prime is positive, the derivative with respect to income is positive, but the derivative with respect to rate of interest L prime is negative. So if we consider the sign, and if we take into account the sign, then we would have to eliminate the negative sign, because k prime is based on a negative phenomenon, and the total sign of the right hand side, which tells you the value of the slope of the LM function, the real LM function, which is dr by dy, is k prime by L prime. By eliminating the sign, it becomes positive. So we have seen two things, that the shape of the LM function is upward sloping exactly like a nominal LM function, the real LM function is also upward sloping. The slope of the LM function is also positive, just as we could see in the case of a nominal LM function. Now let us see what are the implications of fiscal policy and monetary policy in the case of real ISLM functions in an economy. First of all, let us consider the monetary policy. We have a real IS function which is downward sloping. It is designated as IS. We have a real LM function which is designated as LM0, and this is upward sloping. To start with, they intersect at point E and establish the rate of interest as R0 and the level of income as Y0. Now, suppose the nominal money supply increases while the price level remains constant. Then, as we have seen, with an expansion of the nominal money supply, the LM function moves outward to the right, and the new LM function would be LM1. At LM1, given LM1, the intersection would be IS intersecting with LM1 at point E prime. This is the new equilibrium, and at the new equilibrium, the rate of interest is R1 and the level of income, the equilibrium level of income, is Y1. But let us just consider if the rate of interest were, if there was no change due to the LM, what would happen? If the rate of interest were to remain R2, then if the rate of interest is lower, then we would expect that the income could actually increase up to Y3. If it is Y3, then what happens is that there is some kind of excess supply in the product market, and this is known as full expansionary income. But in fact, because this excess supply is not sustainable in the product market, so the economy moves along the IS curve upwards till it reaches an equilibrium at E prime. Hence, the effect of an increase in nominal money supply, which is nothing but monetary policy, the effect of monetary policy, the impact of monetary policy is to bring down the rate of interest and to achieve a higher level of real income. The income increases from Y0 to Y1. Now let us consider fiscal policy. The IS function is IS and the LM function is LM. They both intersect at the point E such that the rate of interest is R0 and the level of income is Y0. This is the original equilibrium. Nothing has yet happened in the economy. But suppose government expenditure increases. When government expenditure increases, the IS function shifts outwards or rightwards, and the new IS function is I prime S prime. I prime S prime intersects with the existing LM function at a higher level, which is E prime. The rate of interest has gone up from R0 to R1, and correspondingly the level of income has gone up from Y0 to Y1. Suppose we were to consider the original rate of interest R0, then what would happen? With an expansion of government expenditure, for instance, the IS function would shift from IS to I prime S prime. What would you expect if nothing else were to change in the economy? The income would increase from Y0 to Y3, and this is known as full expansionary income. Whereas if we were to consider this in the case of a Keynesian economy, this would be the impact, and there would be an increase in government expenditure and the economy would move forward from Y0 to Y3. As I have just said, this is called full expansionary income. But in a modern economy where we have ISLM curves and where we analyze on the basis of ISLM curves, this does not happen. the intersection, if for instance, if the rate of interest remains are 0, then this is a point of disequilibrium. On the other hand, if we consider E prime, then this is a new point of equilibrium. Okay, IS and LM are intersecting, and correspondingly the rate of interest has gone up. Now, what happens in this case is that when the government spends more, then it has to somehow recover this excess expenditure either through taxes or through borrowings. Suppose the government borrows. When the government borrows, then as a result of open market operations, the rate of interest is bound to go up. When the rate of interest goes up, then private investments suffer, and this is what is called crowding out effect. So, a part of the government expenditure which could have led to full expansionary income is compensated by a reduced private investment. As we have said, this is known as the crowding out effect. So, what we see is that fiscal policy is actually an expensive policy, because although there is expansion, the expansion is not really full expansion in the economy, 1. And 2, the rate of interest has gone up. So, it is a costly policy, and it has implications. If the rate of interest goes up, it is likely that in the next round the price level would also go up. So, between the two policies, monetary policy and fiscal policy, we can clearly say that monetary policy is both more effective and it is also cheaper as a policy. Fiscal policy, on the other hand, is not so effective. Fiscal policy is a double-edged weapon. When the government expands its expenditure or investment, it hopes that income would increase, but at the same time it also leads to a reduction in private investment. There is a crowding out effect. Now, let us see in a nutshell what all we have seen. First of all, we have seen how the asset market is equivalent to the money market, as we have always been calling it. The asset market refers to the demand for real cash balances and the supply of real cash balances, and equilibrium takes place when small m, which is the demand for real cash balances, when nominal demand for nominal cash balances is deflated by price, is equal to m bar, which is the exogenous money supply, divided by P. This is the equilibrium condition in the asset market. As far as the derivation of the LM function is concerned, real LM function is concerned, here everything that we are considering is in real terms. The real national income, real rate of interest, real money supply and real money demand. We see with the help of a 4-quadrant diagram that the shape of an LM function is just like of a real LM function is just like the shape of a nominal LM function. It is upward sloping. And then we have also seen with the help of a small derivation that the slope of the LM function is also exactly like the slope of a nominal. The slope of a real LM function is just like the slope of a nominal LM function. It is positive. Finally, we have seen that the effect of fiscal policy is ambiguous because it does lead to an increase in the level of income, but at the same time it leads to a rise in the rate of interest. In the case of monetary policy, we notice that expansion actually proves to be more effective because national income increases, but it is not with a cost as in the case of fiscal policy. The rate of interest actually declines. So, if we compare the two policies, then fiscal policy is likely to give rise to an increase in the rate of interest, and also subsequently maybe it may lead to also inflation. And on the other hand, monetary policy actually leads to expansion, and it also leads to a low cost economy because the rate of interest is low, and in future the price level may be kept under arrest. Stop.